Welcome to another episode of The Dish TV. I'm Renita Malhotra Hora, Head of Marketing and Communications here at SRI International. And I have with me today Aaron Lawson. He is the Assistant Lab Director of our Star Lab. Hi, Aaron. Great to have you on the show.
Thank you. Nice to be here.
What we should probably do is start out by understanding in a little bit more depth what the Star Lab is. What does it stand for? And why is it so important? Because it is. It's a very important lab that we have here at SRI.
So STAR stands for Speech Technology and Research, and it's a laboratory that is essentially focused on anything related to natural speech. Laboratory originally started as a way of doing speech recognition around 30 years ago, pioneering what later became commercial speech recognition. So the Nuance company, which was actually just acquired by Microsoft. And that was the first real commercial use of speech recognition technology, which is basically converting audio into text. And since then, we've expanded our focus into other areas of speech while continuing to work in speech recognition, but in more defined domains and domains that are not general purpose, but low resource languages, very difficult and hostile audio conditions. So changing the focus of our research from being a general provider to working in specific environments. Other technologies that we're developing now are things like speaker recognition and voice biometrics. This is the ability to detect who's talking based on their voice. Language ID is another one. Speech activity detection, detecting where there's speech in very noisy communications. Machine translation from speech is another area where we work quite heavily. And similar to speech recognition, those could be very hostile and noisy signal conditions, languages that have no writing system or that have very little data and that are of low commercial interest, but high interest for other reasons.
And then, Aaron, you mentioned that some of this work that we do at the Star Lab actually goes beyond voice. You mentioned signal type problems and specifically radio frequency communications and how this fits into biometrics, confidence, calibration, explainability. Can you explain?
So, in the world of biometrics, of course, is the radio frequency domain of signal processing. And this came about from work that we were doing where you were trying to do a live capture of audio. For example, if you have emergency situations, you may have many different groups working together, descending on an emergency situation, and they are not necessarily all communicating across groups very well, but they can communicate within their own organization quite well. They have the same, walkie-talkies, etc. So if you were someone who was, say, FEMA, interested in making sure everything is going well and that people were going to the right areas and that everyone knew what was going on in the general area, you would want to be able to process all the stuff that's going on in the audio space of that emergency in real time. So in those cases, what you need to know is not just, all right, here's a frequency where someone's talking on and that person is relevant to the emergency, but you want to know who are the people that I don't know about that are talking about the emergency and our first responders that I need to be able to understand what's happening there. And in order to do that, you need to be able to scan the RF spectrum in the zone where this kind of communications is allowed and pick up transmissions as they're coming in and then be able to link them and say, okay, this transmission here and this transmission here is really from the same person. Mm-hmm. And in order to do that, you need to be able to automatically be able to decode all of these signals by examining the signal in real time and saying, okay, this is an AM signal, with this kind of parameters used, or this is a digital signal, and be able to do that in real time. So what we did is took our tools from speaker ID, language ID, et cetera, the machine learning tools, and instead of training them on audio, we trained them on the raw RF. Mm-hmm. To be able to see things like, can we tell that this is actually a voice communication and not a modem or something else? Can we tell what encoding is used in this signal so that we can then automatically demodulate it and understand it? So it's sort of a new application of these deep learning techniques in a related domain in terms of, it's a time domain signal with frequency and time components, but completely different in terms of its form.
Very interesting. So, one of the things that you mentioned when you sent us your notes was this idea of audio triage for specific audiences. Can you tell us what that is?
Triage is essentially dealing with massive amounts of audio and trying to pull out important information from that audio. Case in point would be for law enforcement purposes. You have an event, say the Boston bombing, which was a huge event, and where people really struggled to understand what exactly went on and really had to do things manually. So they had to listen through or watch through tons of videos to see what was going on, what is in common for that. There's tons of media examples of everything that happened. The big problem is, how do you deal with that massive amount of data and be able to identify what's in common? What are the people involved, and how do they relate to known people in the world? So that's the triage problem, processing massive amounts of data automatically to be able to provide links. So in the case of the Boston Massacre, they had mostly video, but I'm sure they also had audio. You have to go through all of the audio that people have said, I collected this on site at the time of the bombing, and listen to it as a human. What you could do instead is use technology that goes through this audio automatically and says, this file here, this file here, this file here are all happening exactly when the bomb went off. The reason I know this is I can detect a bomb blast. Okay. Now you know when it happened. Okay. Now you go through all the audio and say, can I detect voices, plus or minus 5 minutes around the bomb blast? Okay. We've got tons of videos with a lot of audio in it. Can we pull out voices? Okay. And, then keywords. All right. Is there someone saying something that you just would not expect? You want to be able to know that. If it's something related to bombing, especially, that they may be talking amongst themselves. Is there someone who is at this and who has an extremely stressed out voice? All right. Because people who are about to let off a bomb are going to have, stress factors in their voice that are going to be very salient and you may be able to pick it out. So that's a very abstract example. And none of that happened in the Boston bombing because it was too long ago. But it's just an example of how you would use triage to do link analysis on a massive scale. Of course, you would also coordinate that with the video, for sure.
Aaron, can you tell us about how the STAR Lab links up or collaborates with other divisions or groups at SRI?
This is one aspect of SRI. I mean, I've worked at other places before. This is one aspect of SRI that is very different from most organizations where stovepiping tends to be very rigid and the rule. So I remember one of my previous organizations, our worst enemy were the people sitting around the corner from us because they were competing for the same funding with us. And at SRI, that is very much not the case. There is actually legitimate collaboration, even between different divisions, with people who really, may not even know each other to start with. So there's an active work to reach out and bring people in who are the experts. And that's worked out very well. So within our division, within the ICS division, we work quite frequently with several groups, including the Artificial Intelligence Center, Karen Myers, who we talked to a few weeks ago, her group. Within that group, we work very closely with the Perceptual Computing Group. They are pioneers in face recognition. So in the Semaphore program, they're providing a lot of assistance in the face recognition and visual aspects of things. So is the Center for Vision Technologies, who are able to do detection of puppeteering and other kinds of media manipulation approaches. Puppeteering is basically when you create a fake persona, but it's based on a person actually doing the motions, which can be very successful. So they're working on that in the Semaphore program. And then also within the AI Center, the San Diego group, which works mostly on text, is playing a very heavy role in the Semaphore program on the same team with us to be able to process text, detect when text is generated, and to create a logical framework in which to make decisions about whether a specific multimedia document is fraudulent or not. So to be able to do the logical inference on the information provided to make an informed decision. So there's a lot of collaboration that goes on at SRI.
Thank you, Aaron. That is very enlightening, as always. Thank you for joining us on this episode of The Dish TV.
Well, great. Thanks a lot.